Hello friends and welcome to a new session with edupediaworld.com, your favorite portal for online education. This shall be the last session on measures of dispersion, and the ongoing topic of discussion is the standard deviation. Today we shall see the modified formula or the shortcut formula to find the standard deviation, and this in particular would be useful when we have a problem involving decimals or larger numbers. We had seen that when we have a problem with decimals or large numbers, it's difficult to square them, and as a result the calculation becomes cumbersome. To make it simple, to make it short, we shall be using the formula based on deviation method and the step deviation method. Yes, exactly. You have seen these two methods when we were discussing the measures of central tendency, and you can refer back to the videos on arithmetic mean to revise your concept of deviation and step deviation methods. Before we proceed any further, let's recall the formula which we had seen previously. To find the standard deviation, we first took up the formula based on the raw data, and then we took up the formula for frequency distribution. And in both of these cases, if you recall, we had seen two different forms of the formula. And of course, when we are taking the standard deviation, we have the standard deviation given by the symbol sigma, and also when we square them, when we square the value of standard deviation, we would get the variance. So the basic formula to find the standard deviation when we have raw data was simply the sum of the square of the deviation of individual data from the arithmetic mean divided by the total number of data, and then the positive square root of this value. In case of variance, it's the same, except that we will not be finding the square root of this, or in other words, if we square the value of standard deviation, we get the variance. We had modified this formula, and the alternate formula used was summation xi square divided by n minus summation xi by n the whole square, and then the positive root of this. We used to say this as the mean of squares minus the square of mean, because this quantity summation xi by n is nothing but your actual arithmetic mean. In case of variance, we shall be writing it as summation xi square by n minus summation xi by n square. Now in case when we had frequency distributions, the formula, the basic formula to find the standard deviation was the same as we have here, except that we will have a fi. This quantity would be multiplied by the frequency value, so we will have summation fi xi minus x bar square divided by n, and in case of variance it's the same, except that we will not have the square root. In fact, we will be dividing it by capital N, which is the sum of the frequency, and the modified formula is summation fi xi square by n minus summation fi xi by n the whole square. Yeah, and just squaring this quantity we will have the variance, and so it will be summation fi xi square by n minus summation fi xi by n the whole square. Yeah, and remember, these are the absolute values. To find the relative measure, that is coefficient of variance, the formula in all these cases are, after you have found the standard deviation, we simply take the value of standard deviation divided by the arithmetic mean and multiply it by 100. So this is the coefficient of variation or the relative measure. Alright, so now let's take the modified formula based on the deviation and the step deviation methods. Now this we have got based on an important property of standard deviation, which says that the variance of a distribution is independent of change of origin but not change of scale. So we have it independent of change of origin but not change of scale. Now what is this change of origin or change of scale? So let's understand them one by one. Change of origin. Let's say we have a variable x, and the values of the variable x are denoted on this number scale starting from 0, 1, 2, 3, 4, 5 and so on. Let me define another variable d, and the relationship between x and d is given by x minus a constant, say 3. Now here, when we subtract the values of x by a certain constant value, I'll be getting d. So what will be the equivalent value of d here? Yeah, when x is 0, my d will be equal to 0 minus 3 equals minus 3. So the value of d here is minus 3. Let me use another color. So d would be minus 3 here. Here in place of 1 it will be minus 2, minus 1, 0, 1, 2 and so on. Okay, now you see that x has its origin here, whereas for d the origin has shifted to this point. It has shifted from here by 3 units to this point. This is the origin. Okay, what has brought this transformation? We see that it has come by subtracting a value, a constant, to the previous variables, to all the values of the previous variables. In the same way, even if we would have added, the origin would have shifted from here in the other direction. So what we understand is that when we add or subtract a constant to a variable, to all the values of a variable, we actually, what are we doing is we are shifting the origin. Yeah, so it's add or subtract all the variables, all the values of the variable by a constant. Okay, and if you recall, even while we were solving the problems on arithmetic mean, we did the same. We used to while using the deviation method, we used to add or subtract artificial mean to the values of x to get the value of t. Okay, in the same way, let's see what's change of scale. Let's take an example. Let's say that there is some commodity which is given in grams, in the scale of grams. So let's say 100 grams, and I want to write the value in kilograms. Okay, so what do I do to get the equivalent value of kilogram? We know that the relationship between gram and kilogram is that 1 kilogram equals 1000 grams. Okay, so if we have a commodity given in kilograms, and if we want to shift it to grams, what I do is I divide it by 1000. Okay, so the equivalent value is 0.1 kilograms. Okay, similarly, if we have something given in kilograms, and I need the equivalent of in grams, I multiply it by 1000. So now this is a scale, and this is another scale. This is smaller scale and this is larger scale. If I have to shift from smaller scale to larger scale, I am dividing the value, and when I have to shift from larger scale to smaller scale, I am multiplying the value. Okay, so in change of scale means, let me write it here, change of scale means to multiply or divide all the values of a variable by a constant. Okay, so here when we have a value x, if I want to get it transformed into, say, another variable, I'll be using another variable u, and u will be equal to x divided by a certain quantity. And if you recall, we used to, in step deviation methods, we used to write it as x minus a, which was actually this is the change of origin, and then change of scale by dividing it by the common value, which is h. Okay, yeah, so these are the thing. So now we'll be using these two, and using these two, let's derive the formula for these. We have a variable x, and then shifting from x, the deviation method will be using d, and in the step deviation method we'll be using u. So these are the three variables, and the relationship between them is, you have, let's go to step deviation method. U is equal to x minus a by h. Okay, u equals x minus a by h. This is what is the standard one we have been using. Let me call this as my first, and I can write this further as x equals u multiplied by h plus a. So what I've done is I've taken this h here, so it will become u into h, and this minus a goes to the other side of the equals and becomes plus a. So it's u, so I can write x equals a plus u into h. Okay, we'll be using, in fact, this, never mind, we'll write it as 2, and we have our standard formula of variance as summation fi xi minus x bar square. Okay, the variance of x is this. Let me call this as 3. Now, to execute this, we used to take summation fi multiplied by xi. Okay, in place of xi, if I put this, this quantity what we have here in the second equation, if we put that here, we will have summation fi times, in place of xi we will have a plus u into h. Expanding it further, we will have summation fi into a plus summation fi into u into h. Now a being a constant can be taken out of the summation sign, so you'll have a times summation fi plus, here again h is a constant, so I can write it here, h times summation fi into ui. Okay, now divide this whole thing by n. Divide by n, we will have a summation fi by n plus h summation fi ui by n, and this is your summation fi xi. Of course, when I'm dividing it here, this side also gets divided by n. So what we have now, if we look at this summation fi xi by n, what is this? Have we seen it before? Yeah, exactly. This is nothing but our arithmetic mean of x. So I can write it this as x bar, and this would be equal to a times summation fi by n plus h times, now what is summation fi u by I by n? If we look at this and this quantity, we see that they are similar, except that here we have the variable x and here we have the variable u. So in other words, this is nothing but the mean of u's. So I can write this as u bar. Okay, so now I have x bar equals a. Now what is summation fi by n? Fi, summation fi is nothing but n, so both of these would cancel out each other, and as a result we will have x bar, x bar equals a plus h times u bar. Let me call this as equation number 3. Okay, now coming to our actual formula, sorry, we have already used this as 3, so let me call this as equation number 4. Coming to our actual formula, which is x, that is this formula, let's now develop this using the other things which we have got. So we will have sigma x square equals summation fi. Now we have xi here, xi, I can, that is in equation number 2, I can use that here. So I'll have xi, which is equal to a plus uh, right, minus x bar, I can take that from equation number 4. So I'll have a plus h u bar. Okay, and the square of the whole thing. So I'll have a square here. So what have we done? We have simply substituted uh, 2 and 4 in 1, sorry, in 3. Okay, so we have got this. Now here if we look at this a and a will cancel out each other because it's a constant. Here we have a positive value of a and we have a negative value of a, so I can cancel out these two. So I'll be left out with sigma x square equals summation fi times uh minus u bar h square. Now we know h is a constant, I can take it out, so I'll have summation fi h, of course there's a square, so h square times u minus u dash square. Being constant, I can write it outside the summation sign, so I'll have h square summation fi times u minus u bar square. Now if you look at this formula and this formula, look at this formula and the formula here, we see that it's exactly the same, except that we have this h coming here. See, you have summation fi multiplied by the variable xi minus its mean. Here it is summation fi times ui minus its mean. The only thing is that it's multiplied by h. So when, and this both represents sigma x bar square. So we see that when we transform this x by using another the relationship x minus a by h, what happens is that the final formula of variance is multiplied by h square. Is that clear? When we work out problems, you'll understand it in a better way. We'll be shortly taking the problems based on these formula. Okay, let me just summarize this. You have sigma x square. Let me write the alternate formula here. It will be easy for you. When you use the step deviation method, the whole formula will be multiplied by a constant h square, and your formula, since we have used the step deviation method, we, instead of x, we will be using h, so it will be summation fi ui square divided by n minus summation fi ui by n the whole square. If you recall, our previous formula used to be summation fi xi square by n minus summation fi xi by n the whole square. So instead of xi, I'm simply replacing it by ui, and to negate the impact of this change of scale, I'm multiplying it by the factor h, which we used to make this change. Okay, now this is your step deviation formula. Sorry, step deviation, let me write it as step deviation. And when we use simply the deviation, of course, as we had seen that deviation is based on change of origin, and change of origin is independent, therefore there will be nothing coming here. We'll straight away have summation fi di square. Yeah, to bring about this change of origin, we used d, the variable d. Okay, minus summation fi di by n the whole square. Okay, where your d was equal to xi minus a. Yeah, so precisely, let's see what is the formula which we have for deviation is this, and for step deviation is this, summation fi ui square by n minus summation fi ui by n the whole square. So now let's take some numerical problem based on these two concepts. Here we have a variable x and its values given, and if you recall, we have already solved this problem using the direct method. So let's do this now by using the shortcut method which we have seen just now. And since here we do not have the frequency given, this is simply a raw data, will not be able to use the step deviation method. We will use directly just the deviation method, and for the deviation method we first need to find the deviation d. D is simply the difference between the value of x and the artificial mean. So I need to fix the artificial mean from among these numbers. So let's take a middle value, say 50, and let's mark this as our artificial mean. So 50 is our a. So now d would simply be x minus a, which is 50. There's my deviation. Let's do this for all the cells here. So here I have the values of d. Next I need to find the square of these terms here, the square of deviation. Is simply the value of d raised to power 2 for all the cells. It's this. Yeah. Next I need to find the sum. So the sum of the deviation is 10, and the sum of the square of deviations would be 366. Now let's go back to the formula and see since we are using the deviation method, the formula to find the standard deviation is summation. Now in our case we do not have the frequencies given, therefore it will simply be summation di square by n minus summation di by n the whole square, of course the square root. So now this term, if we look at this term here, it is summation di by n, which is nothing but the mean. So I'm squaring the mean. I call this as square of means, and this is the mean of square. Yeah, so let's find the square of mean and mean of square. First mean of square, and that will be, this is our square value, the sum of the square of the deviations divided by the total number of data, which we see here is 10. So mean of square is this, and then square of mean will be this value divided by the total number of data, which is 10. It's 1. So now here I'm ready to find the standard deviation. The standard deviation will simply be the square root of the difference between the mean of square and the square of mean. So here it is 5.96. And what about the variance? Variance simply is the square of this value. So this value raised to power 2 will give us the value of variance, which is 35.6. And if you recall, we've already done this. These were the answers which we got previously by the direct methods. So that way we are verifying our answers. And then next, let's see what will be the coefficient of variance. Coefficient of variation, we know, is the ratio between the standard deviation, that is this value, and the arithmetic mean. So what is the arithmetic mean here? Well, you can directly find the arithmetic mean by taking the sum of these and dividing by 10, or since we are using the step deviation method and we have the data, let's take the value of mean as this. So if you recall, it's the formula to find the mean using the step deviation method is the artificial mean A, which is 50, plus the summation of di by n. So summation of di is 10 divided by the n value, which is again 10. So that gives me the mean, and the mean here is 51. So my coefficient of variation will be 5.96 divided by the arithmetic mean, which is 51. Okay, so the coefficient of variation is 0.1169. So well, so that is the process of doing it using the deviation method. Let's take one more problem and solve this using the step deviation method. This time we have the frequency distribution. We have got the x and f, and again we had solved this problem also previously. So again it will be a repetition and a verification of the previous answers. Here we are going to find the value of u first, since we are using the step deviation. Now to get the value of u, I need the artificial value of mean, that is a. Let me fix it at a center point here. A is, let's say is 14, and also I need the value of h, the common ratio, and here we see that the numbers all vary by 1 unit, therefore h is 1. Okay, let me mark both of these with a different color to identify. So my u now will be x minus a, which is 14, divided by h, which is 1. Of course, dividing by 1 will not make any difference. So these are my values of u, I need to find the square of these. So u raised to power 2, the square of these for all the values in this column are here. Next, I need to find, if you recall the formula, yeah, it is summation fi ui square by n minus summation fi ui by n the whole square. So I need to find the product of f and u as well as f and u square. So let's do that here. It's f multiplied by u and f multiplied by u square. So f multiplied by u simply is f in this column multiplied by u, which is here, and f multiplied by u square will be again the value of f here multiplied by u square, which we have found here. Okay, now drag it down to all the cells in both these columns. Yeah, so here we have fu and fu square. Next I need to find the sum of all these. So of course I need to find the sum of f as well. Sum of f would be the sum of the values in this column, that happens to be 76. Next I need to find the sum of fu and fu square. Okay, so these are the values here. What next? Yeah, I need to find the ratio summation of fu square by n and summation of fu by n square. So let's find the ratio here, and these are nothing but the square of means and mean of square. So the mean of the square would be this value divided by your n. Okay, and square of mean would be this value divided by n, and we know 0 divided by any number is 0. Again, when we square it also we will get the same number, 0. So directly now we are ready to find the standard deviation. The standard deviation will be square root, in fact it is h multiplied by, so h again is 1, so that's not going to make a difference, but still let's do it in process. H multiplied by square root of the difference between the mean of square minus square of mean. I've not squared it because it's the same whether we 0 raised to power 2 is the same, but anyways let's do it in process. So let's do the square of this number raised to power 2. So here the standard deviation is 1.98. yeah, and the variance is simply the square of this number, so it's this raised to power 2. It's 3.94 or 3.95 because rounding it off. And finally the coefficient of variation we know is standard deviation divided by mean. Let's find the mean here, and since we are doing the step deviation, let's find the mean using the step deviation method. If you recall, mean, the formula in step deviation method is the artificial mean, which is here a 14 plus the summation of f into u, which is this number, divided by your n, that is summation of f, and that is to be multiplied by your h, which is 1, and that happens to be 14. So our arithmetic mean is 14, and then finally coefficient of variation would be standard deviation divided by the arithmetic mean, and that is 0.141. So these are the values of the standard deviation, variance and coefficient of variation for this problem. Okay, so I hope it was easy and simple to understand. We have taken both these, we have taken the deviation and the step deviation methods for the raw data as well as for frequency distribution. Just to consolidate our understanding, let's take one more problem, and this time we have grouped frequency, a very simple problem, small number of data, and the working is the same when you have a grouped frequency or ungrouped frequency. The only difference is that in grouped frequency we need to find the values of x. So here stop me for a while and try solving this. Find the standard deviation, the variance and the coefficient of variation using the step deviation method for this. Alright, so now let's do it together. First we need to find the values of x, which is nothing but the mid value of these age group given here. So the mid value of 20 and 25 is 22.5, the next is 27.5, 32.5, 37.5, 42.5 and finally 47.5. So these are my mid values or the x. Now I have the x and the number of person is nothing but f. So we have the x and f. I'm ready to proceed. Let's find the value of u. To find u, I need an artificial mean. Let's take 32.5. Okay, so let me write that here. A and h. What is h? H is the common ratio, and this time we see that the numbers are the product of each. The common ratio is 5, so h is taken as 5. So now u would be x minus a, which is 32.5, and then divided by h, which is 5. So this is my u value. Okay, I need to find the value of u square next. U raised to power 2 is simply the number here raised to power 2, and then drag it down for all the cells. We have u square. Next, exactly, I need to find the product of f u and f u square. So we have f multiplied by u in this column and f multiplied by u raised to power 2 in this column. So here it is f multiplied by u, and here we have f multiplied by the square of u. And drag it down for all the cells in these two columns. We have these numbers ready, and now we can find the sum of all these. We need to find the sum of the values of f to get the value of n. That's here 480, and then we need the sum of these two, which are minus 220 and 1310. Next I need to find the ratio, that is this number divided by f, which is, and also the fu square by n. Okay, and now the standard deviation. The formula is h, which is 5, multiplied by square root of the difference between this number and the square of this number and the square of this number, this raised to power 2. Yeah, so my standard deviation is 7.93. Rounding it off, it will be 7.94. The variance is simply this value raised to power 2. And coefficient of variation, of course we need to find mean. we need to find the value of mean, and here let's use the shortcut method to find the value of mean. The formula is A, which is 32.5, plus summation of f multiplied by u, which is this value, divided by the summation of f, that is n, which is 480, and then that multiplied by h, which is 5. So our mean is 30.20. Rounding it off, it will be 30.21. And now my coefficient of variation would be the standard deviation value divided by the arithmetic mean. Okay, so we have now the all the required values here: the mean, the standard deviation, variance, and the coefficient of variations. And with that, we have completed this exercise, and I'm sure by now you must have understood these two shortcut methods. And as I said, these are handy when you have problems involving larger numbers or bigger numbers. So you can use these methods, the shortcut methods, wherever you have a problem which could not be, or which is difficult to solve by the way of direct method. Alright, so let's conclude by taking a small assignment. Here I have given you a small set of data, and I want you to calculate the standard deviation and the coefficient of variation for this. Let me read the question once, explain it to you, and then you'll be solving it yourself. Maybe I'll be posting the solution of this in any of the subsequent videos. A welfare organization introduced an educational scholarship scheme for the school-going children of a backward village. The rates of scholarship were fixed as given in the following table. You have a table where you have the age group in years given for the children, and the amount of scholarships per month in rupees for each of these age group. Okay, the ages of 30 school-going children were noted as the numbers given here and in years, and then you need to calculate the standard deviation and coefficient of variation of the monthly scholarship. Well, the key here is that you need to calculate the standard deviation and coefficient of variation of the monthly scholarship. And here in our first column we have the age group given. The monthly scholarship amount are given here. So you will have to first decide what will be the value of your x and f. Once that's done, I think the problem is trivial. Of course, you need to solve this using the shortcut method. Let me write that here. Use the step deviation method. Okay, so I've given you a hint as well that you're not going to calculate the values as it is as given in this table, but you need to do something so that you find the standard deviation and coefficient of variation of the monthly scholarship, not of the age group. Okay, so rearrange the data once and then solve this question, and for the solution keep watching Edupedia World videos. Thank you.